of radius capital R, charge Q, and density rho. So now I want the electric field strength at point P1. So this is the Gaussian surface. Here I assumed a Gaussian surface. I assumed a Gaussian surface of radius small r. You can see at point P1, we have to find out. Now, what is this? This is a charged body, no? Look at the distribution of charge. Is it distributed symmetrically with respect to Gaussian surface as it is? Then the whole charge will appear like a point charge kept at the center of Gaussian surface. I can show, but again, students will think that something charge sphere will become point charge. No, not like that. Charge sphere will remain as charge sphere. But in calculation of electric field, we can treat now this whole charge as a point charge kept at center of the Gaussian surface. If this whole charge plus Q is at center of Gaussian surface, tell me what is electric field strength? How much you are going to write? How much electric field strength? This should be equal to KQ by R square, where R greater than R. Similarly, what is the potential? KQ by R. The whole solid sphere, the charge, this whole, so like a solid sphere charge, what when you can treat like a point charge kept at center of Gaussian surface. Very simple, no? It is like, agreed, this one? Now on the surface. So I'll vary this smaller, I'll make capital R. So on the surface, KQ by R square, where R is equal to R. Potential on the surface, KQ by R. Vs, you write it. Huh? So like this, we can determine the electric field strength due to uniformly charged sphere. Very simple, better remember, very useful for you. Now, what about the field, uniform or non-uniform? Non-uniform, you can see as smaller varies, but this formula is applicable strictly for the distance only if the point lies outside the sphere. What about point if the point lies inside? You cannot apply this formula. We have to derive separate one. Let's come for the next one here. Yeah. Now, where is the point? Now, the point P3 lies inside. I want the electric field strength inside a uniformly charged sphere. So what is the charge density of this? Rho. How to calculate this one? So I'm going to take help of a Gaussian surface. Okay, what is this? Like a Gaussian surface, and also we have to calculate net charge first enclosed here. So this is a Gaussian surface and also like a thin shell. Any method? Go back to the gravitation chapter. We had a discussion on this. How much of charge enclosed by Gaussian surface is what I should calculate. What is the total charge of this? Q, capital Q. Charge enclosed, let it be Q in. Can we calculate Q in? Here is the field. So I come to the Gauss law. So first Q in will calculate. So what should be the Q in? Rho into 4/3 pi RQ. So what is the charge enclosed by the Gaussian surface? Net charge enclosed by the Gaussian surface. What is the radius of this Gaussian surface? Small r. I shown it here. Let it be here. Huh. Small r. So what is the charge density of this? Rho, uniform charge distribution. Here also I'll write rho. Huh? How much of charge enclosed by the Gaussian surface? Density into volume of this volume of the charge enclosed in this Gaussian surface. So 4/3 pi r cube. Okay, I'll get into the Q in equal to E bar dot ds bar. So how the n cap will be for curved surface should be radially outward. No, look at it at all points. What is the electric field strength? Will be constant, and everywhere E bar parallel to n cap. So cos 180. So cos 0 will be 1. and at all points, it will be constant. So this will come outside. So integral of ds. So what is q in? Now I'll substitute here. Rho 4 by 3 pi r cube. So this will become rho 4 by 3 pi r cube. The field strength, I don't know. What is surface area of this? What is the ds? So yes, like I'm not understanding what do you mean by ds. Agree this. So this will become elemental structure like a patch. So integral of ds, what it should give? 4 pi r square. So when r get cancelled, so 4 pi get cancelled. So this will become rho. Okay, this q in, oh, yeah. 4 by 3 pi r cube. 4 pi will be no rho r3. I think. Sorry. Some. This f naught, no. No, this will become. So what is the expression for electric field? EP3 equal to rho r by 3 epsilon. Keep it here. So this will be very, very important. What is the field? Field inside. Some I can also use symbol in. The Gauss law is like q in by epsilon naught. Flux equal to EP3 dash or net charge enclosed by the epsilon naught. Now, what is rho? Charge density. So this if I write it, E in EP3, this should be equal to Q by 4 by 3 pi R cube 3 epsilon naught R. So this will become QR 4 pi epsilon naught R cube. I think this will be very easy for you to remember. Remember this formula and remember also this formula. If they give charge, remember this formula. If they give something density, remember this formula. That's why I brought both the forms. If they give charge of a solid sphere, use this formula. If they give density something, take help of this formula. Look at now the field. Will it be like as smaller increases? So the field strength will also increase, no? Will be maximum on the surface. So if I go for the variation, how the electric field will vary. And outside it will be decreasing. Already is there. We have discussed in gravitation chapter, nothing big. There's a variation of the electric field strength. At center, how much it will be? 0. As you move radially outward, the field strength will increase. On the surface will be maximum. Outside, it starts decreasing. Outside, again, you can't use this formula. Strictly, what is smaller? Any condition for smaller? Smaller should be less than R. Smaller should be less than or equal to R.